Hi, good morning, afternoon, evening, whenever you're watching this. Today's video is on 6.4, specifically the side splitter theorem and the angle bisector theorem as it pertains to similarity. So they're applications of similar triangles. We're going to be seeing triangles that are embedded. So you'll be seeing two triangles in one and things like that. Let's look at the first example, okay? So, or let's read the objective, which is to describe and apply a line parallel to one side of a triangle divides the other two proportionally. And that's this right here. That is called the side splitter theorem. So I'm just going to write that here actually. So we're going to call that, this is the side splitter theorem. Okay. And an angle bisector divides a segment into segments proportional to the corresponding sides of the triangle. That's the angle bisector theorem. Now there is a proof here that I'm not going to go over in too much detail in this video, and this is the part one. What I advise you to do is watch this part one, and then in part two of this video, we will go over this proof that's down here, okay? We're going to talk about exactly what the triangle proportionality theorem or the side splitter, and I keep writing that over and over again, right? And it says AKA the side splitter theorem right here, so I technically didn't have to rewrite that. I'm going to put this on focus. Hopefully we can see better once I do that. Okay, so it says that a line intersecting two sides of a triangle is parallel to the third side if and only if the line divides the two intersected sides proportionally. So what does that mean? Well, as you can see, I'm kind of playing with the exposure here and the focus so that you can see this. So literally what this means is if you have a parallel line right here, set of parallel lines, okay, what will happen is those parallel lines, and especially in particular in a situation like this, these parallel lines automatically indicate that you do have a similar set of similar triangles. And why I say triangles is because there are two. So there's this one right here, which is the smaller one. And then there's the larger triangle here, okay, which is the larger, like I said. Now, because they both share an angle, they both have this angle R in common. And what also occurs here is that because this is a set of parallel lines, and if we treat this as the transversal, it creates two corresponding angles. Again, as we know, when we have parallel lines cut by a transversal, corresponding angles are angles that are in the same location, right? Relative to the transversal, all right? And so if this is your transversal and these are your two parallel lines, then we have corresponding angles here. What that means is just by the fact that we have these two triangles embedded and we have this set of parallel lines makes triangle URT and SRQ similar by the angle similarity criteria. Okay, so because these are looking at them and looking at the fact that they're embedded triangles, these two are parallel to each other, creating these corresponding angles, and by the reflexive property, meaning a shared side or a shared angle, in this case a shared angle, then we have proportional sides. And specifically, the sides that are proportional to each other are sides QT, okay, is proportional to SU, right? And then TR is proportional to UR. So this is exactly what the side splitter theorem is, okay? It creates a set of proportional sides in these two embedded triangles, okay? And so we're going to see how that works in solving for missing side in a set of triangles, okay? So I actually drew this diagram. I did this here. I did this diagram, and you should do your own diagram as well, okay? So it's not the one that's in green, it's the one that's in pink. And so we're just going to model how to solve a problem like this, right? So I have triangle NCM, which is the smaller triangle, and triangle ACB, okay, or ABC and NMC, all right? So we can tell off the bat they both share angle C through the reflexive property. There's a set of parallel sides, therefore these are corresponding angles. So these two triangles are similar through similarity criteria. All right, so for that reason, we can set up a proportion to figure out what the value of y is. And so I took side BM, and it's proportional to side AN, so I took BM over AN, which is y over 6, and set it equal to side MC over side NC, which is 12 over 10. Okay, once I did that, I cross-multiplied and solved, in which case I got 7.2 for y. So y is equal to 7.2. All right, so let us practice that with the try it out. One more problem, right? Like this, and we're going to do this with the try it out. So it says to tell whether VZ is parallel to segment VZ is parallel to segment or line rather WY. Justify your answer with mathematical reasoning. So let's first of all look at the situation. They're not telling us that these two segments are parallel. Okay, this segment is not parallel to this line, so we can't just go ahead and draw in our corresponding angles because we're essentially being told to really demonstrate or prove whether or not these two are parallel. Okay, and if that were to be the case, it would mean that WV would have to be, or actually, let me write out these letters. WV would have to be proportional to YZ, which would be proportional to WX, and YZ would need to be proportional to YX. So we need to actually plug in the numbers that go here, and what should happen is once we plug in the numbers into the proportion, when we cross multiply, we'll get the same value on each side, okay? So let's try it. So WV is 3 units in length. YZ is 4 units in length. WX is 6 units in length. And YX is 7 units in length. So I'm going to cross multiply, and I get 24 when I multiply 4 times 6, and 21 when I multiply 3 times 7, which means these are not, these are not proportional, okay? So these are not similar triangles, which for that reason means that these two are not congruent, or excuse me, these are not parallel, because parallel lines cut by a transversal will always create corresponding angles. These do not. So these two segments are not parallel. So segment VZ is not parallel to line WY. Stay tuned for part 2.